Let's take a look at section 8.1. So we're starting chapter 8, and chapter 8 is all about a technique called hypothesis testing. So the name of the chapter is just conduct hypothesis tests. So hypothesis tests for one population. You can do it with two populations, but we're going to stick to just one population this semester in our course. So it says section 8.1, the title of 8.1 are the essential steps for hypothesis, I'm going to abbreviate here, hypothesis testing. You've probably heard the term hypothesis. It probably comes to mind when you think of a science class and you make a hypothesis in an experiment about what's going to happen. And in statistics, it basically means the same thing. We're going to make a prediction, or we're going to make a statement about what we think is going to be true, and then we're going to look at some statistical evidence to test it. So, two objectives in this section: write a null and alternative hypothesis for a test involving a population proportion. I'm going to abbreviate and say proportion. And then also compute and interpret a test statistic and a p-value. And we're going to use StatCrunch to help us do that. So what is hypothesis testing? It's a procedure, generally speaking, that enables us to choose between two claims about a population. And we're going to look at a sample and make a decision about those two claims based on what we see in our sample. Hypothesis tests are conducted in all fields in which theory can be tested against an observation. In any level of research, if you ever go to grad school and you ever do any kind of research, it's probably going to involve some type of hypothesis testing. So in this class, we're going to look at a specific way of hypothesis testing with a proportion, but it can extend to other areas and other fields of research. If you're a psychology major, a political science major, anytime you ever do any kind of research down the road, there's a good chance it's going to involve hypothesis testing. So some general examples here. A quality control engineer may hypothesize that a new assembly method produces only 5% defective items. An educator may claim that two methods of teaching are equally effective, and they want to test that out. A political candidate may claim that a plurality of voters favor his election. All of these can be subjected to some sort of hypothesis test, and a statistical verification can tell us what we know or what we don't know about our hypotheses. So, 4 general steps when you conduct a hypothesis test. The first is to hypothesize. So the verb for hypothesis. Hypothesize. State hypothesis or a claim that will be weighed against a neutral or skeptical claim. That's step 1. Then you're going to prepare. Determine how you'll use data to make your decision and make sure you have enough data to minimize the probability of making a mistake. Third step would be compute. So compute, collect data and compare it to your expectation, and we're going to use StatCrunch to help us do that computation. And then the fourth step is to interpret. So interpret, state your conclusion. Do you believe the claim, or do you find that the claim you made does not have enough evidence to back it up? So let's just start with a basic example here. Suppose we have a coin, and the coin is spun on a flat surface. You make the hypothesis that it is more likely to come up tails because that side of the coin bulges out slightly compared to the head side. So to test this hypothesis, you spin the coin 20 times. All 20 times it lands on tails. So I want you to pause for a second. I want you to just think about the likelihood of that happening. If I flip a fair coin 20 times, we would expect about 10 of those times for it to land on tails, right? 50% chance it would land on tails. However, if I spin it 20 times and all 20 times it lands on tails, you'd probably be a little bit suspicious that something is weird about that. If it was truly equally likely that the coin landed on heads or tails after spinning, it would be very unusual to find all 20 tails in all 20 spins. I mean, intuitively, I hope you see that that would be really strange and unlikely that all 20 spins would land on tails. So it's so unusual that you would conclude your hypothesis that the coin is more likely to come up on tails when spinning is correct. So you're taking the evidence that all 20 times all 20 spins landed on tails, and you're using that as evidence to support the claim you made earlier. The claim was that the coin was more likely to come up tails. So what did we do? Those were basically the 4 steps. We just kind of did a hypothesis test in a sense there. So the first step was we hypothesized. We hypothesized that the coin was more likely to come up tails. The second step was we decided to use the proportion of tails in 20 spins to test your hypothesis. So this is the prepare step. We decided how we were going to test our hypothesis. So back up here, that was the prepare step, step 2. Okay, step 3 was then we went ahead and ran the test. So how did we do that? We collected data. And the data we collected was what it did on 20 spins and found that it resulted in 20 tails. And we compared that to our expectation. We kind of talked through it, but our expectation was that 10 of those would be tails and 10 of those would be heads, 50-50 chance of each. If the coin was not more likely to land on tails, you would expect, that was our expectation, about 50% of the spins or about 10 spins to result in tails. However, we noticed that we got 20 tails, which is much greater than what our expectation of 10 would have been. So then we interpret that. So since it is so unlikely to get 20 tails on 20 spins, if the coin was a fair coin, if it was really equally likely to land on heads and tails when spun, we concluded that the coin is more likely to land on tails when spun. There's something special about this coin based on the observation that we made. So let's go back to the first test and talk about hypotheses for a second. So whenever you work with a hypothesis test, you're going to have 2 hypotheses. The first hypothesis is called the null hypothesis. So the null hypothesis is the neutral, the status quo, or the skeptical statement about a population parameter. What we expect to happen in that population. In the last example, I expected 10 of those coins or 10 of those flips to land on tails. So that was my expectation, what we think will happen, what should happen based on experience or based on theoretical probability. And so that contains an equal sign. Every time you look at a null hypothesis, it will have an equal sign in it. The second hypothesis is called the alternative hypothesis. So the alternative hypothesis is also called the research hypothesis, is the statement about the population parameter that we intend to demonstrate is true. It's what we're experimenting. In that last hypothesis, or in that last example with the coin, the alternative hypothesis was that it would have landed on tails more than 50% of the time. So it's what we're interested in testing out, or what we think might be true about the population. The alternative hypothesis always contains less than, or greater than, or not equal. So when you're just looking at the hypotheses, you can tell which is which based on the symbol that they use. So the null hypothesis will always contain equals. The alternative hypothesis will always contain less than, greater than, or not equal to. One thing that's really important about hypotheses is that they are always statement about parameters. We don't talk about our sample when we talk about a hypothesis because we know what's happening in our sample. There's nothing to test or think about or demonstrate. We know what's true about our sample. What we don't know this time is something about our parameter. And so our parameter is what we're always talking about, whatever our population parameter is when we work with the hypotheses. Another note, the null hypothesis always gets the benefit of the doubt throughout the hypothesis testing procedure. We always assume the null hypothesis is true, and then we test our evidence against that to see if we have evidence to support the alternative. But if there's ever a question about it, the null hypothesis always gets the benefit of the doubt. We only reject the null hypothesis if the observed outcome would be extremely unusual if the null hypothesis were true. In other words, think about our coin example. It would be extremely unlikely to get 20 tails in 20 spins if it was truly a fair coin. That gave us evidence to reject that null hypothesis. It is analogous to assume that a defendant in a jury trial is innocent unless proven guilty beyond a reasonable doubt. Okay? So, what do we mean by a hypothesis, or how can we write out a hypothesis? So, one-sided versus two-sided hypotheses. We've got a couple of options here. So, if it's a two-sided hypothesis, the null hypothesis looks like this. P equals some percentage, we call that P naught. The alternative that goes with that would be that P does not equal P naught. A one-sided hypothesis, the null is the same, P equals whatever we think it is, because the null hypothesis always takes equals. The alternative for a one-sided hypothesis that's on the left would be that P is less than P naught. And then a one-sided hypothesis on the right would look like this for the alternative, P is greater than P naught. So let's look at an example and let's write the hypotheses for this example. So it says, during the previous fiscal year, 10% of the orders placed at Firehouse Subs were done so online. In an effort to increase this percentage, Firehouse Subs has purchased ads on Facebook and Twitter. Firehouse Subs gathers data on types of orders placed on a sample of 20 days during the current fiscal year. The question is, has there been a change in the percentage of online orders? So let's write the null and the alternative hypothesis for the retailer. So the null hypothesis is that nothing has changed. The status quo, the proportion of orders is exactly the same as it was last year. So that would be in this case that P equals 10%. So I'm going to make it a decimal, 0.10. Where am I getting that 10%? Because last year, the year we're comparing it to, the percentage of online orders was 10%. So the alternative, which one of the alternatives you're going to choose depends on how the question is phrased. So when it says, has there been a change in online orders? Change means it could have gone up or it could have gone down. So the alternative then would be that P is not equal to 0.10. It could be higher, it could be lower. So that would be a two-sided alternative hypothesis. It's just not equal to. It's changed from the 10%. So is this one-sided or two-sided? Well, this is two-sided because the question said, has there been a change, which implies it could be more or less than 10%. What other hypotheses could the researcher have posed? Well, I think the one that would have made a little more sense is if they said, have online sales done what? What are we interested in? They were trying to get more online sales. They wanted to increase that percentage. So the more obvious question I think would have been, have online sales increased? And if they had done that, then your alternative hypothesis would have looked like this. Oops, not H sub A. So H sub A instead of H sub O. By the way, alternative hypothesis is H sub A. Null hypothesis is H sub O. But we're doing the alternative. So has sales increased? Then it would have been, is P greater than 10%? That would have been a right-sided hypothesis test up here. Okay? That probably would have been a more useful question. Have the sales increased? So the question would have been, is P greater than 10%? They could have also asked, have sales decreased? In which case, then it would have been P is less than 10%. But I think this one is probably the one that makes the most sense. All right, let's look at another example. So in 2015, a Gallup poll reported that 55% of Americans stated that they believe that global warming is caused by human activities. In 2017, 68% of those responding to a Gallup poll believe that global warming is caused by human activities. Assume that the sample size for the 2017 poll was 1,000. Can we conclude that the percentage of all Americans who believe that global warming is caused by human activities did indeed increase from 2015 to 2017? So in what year is the sample represented? So the sample is based on when we took the poll. So the poll that we took in 2017 had 1,000 people in it. So in 2017, that's going to be the sample that we use to test things out. Is the percentage then in 2015 considered a parameter or a statistic? So in 2015, they gave general information. They said 55% of all Americans is what the implication is there. So since they're talking about all Americans, that would be a parameter. While the percentage that they took in 2017, so in 2017, they took a new poll and they surveyed 1,000 people and asked their opinion about global warming. And what they found was that 68% said they believe that global warming is caused by human activities. So since they specifically said that was based on a poll of 1,000 people, that now becomes a statistic. So the question is, has the true population proportion increased in 2017? So what do we know so far? P hat, remember, is your sample proportion. So our P hat, remember P hat is always your sample proportion. So in this case, our P hat is the 68%. And N, remember, is the sample size, so that would be 1,000. The null hypothesis would be that nothing has changed. Assume that nothing has changed. The population proportion is still at 55%. So the null hypothesis would be H naught P equals 0.55. Nothing has changed. We're still at 55%. The alternative hypothesis was that the question said, can we conclude that the percentage of all Americans who believe global warming is caused by human activities has increased? So an increase would mean gone up, greater than 55%. So my alternative would be that P is greater than 55%. And I want you to notice that when you write these when you write these hypotheses, the null and the alternative, these are exactly the same numbers. So whatever you use for the null, the percentage there, you're going to use the same thing for the alternative.